So I have this tube, light shining in the window of the tube. Photons with energy 5 electron volts strike the cathode. The cathode has a work function of 3.0 electron volts, and we have some questions based on this. Think about that first one. 5 electron volt photons strike an electron, has a work function of 3 electron volts. Question A, what is the kinetic energy of the emitted electrons? Talk to your neighbors about this. I'm going to call a name out of the box to answer this question in 30 seconds. All right, let's talk it through. What do you say? So the photon comes in. It's got an energy of 5 electron volts. Hits the surface. 3 electron volts is how much energy it takes to liberate the electron. So it has to raise it up from like inside the metal to the surface. That costs 3 electron volts. How much energy is left over? 2 electron volts. Where does that 2 electron volts go? Goes to the electron. And specifically, where it goes is to the kinetic energy of the electron. So how much kinetic energy does it have? 2 electron volts. 2 electron volts is how much energy it will have. OK, given that, tell me as a group, what potential would you need to put on the anode in order to stop the electrons from reaching it? First off, positive or negative? Negative. Negative 2 volts. 2 volts. Because the electron has 2 electron volts of energy, and it's going to take 2 volts of a repelling potential in order to stop it. So the stopping potential would be 2 volts here. Let's do a couple of exercises with the photoelectric effect now to check on things. Monochromatic light shines on the cathode in a photoelectric effect experiment, causing the emission of electrons. If the intensity of the light stays the same, but the frequency is increased, which one of these applies? A, B, C, or D? Intensity stays the same, but the frequency is increased. Talk to your neighbors about this. And I'll call for a vote in about 30 seconds. All right, let's take a vote. What do we have? People are kind of like all over the map on this one. Well, let's talk this one through. OK. The intensity of the light stays the same, but the frequency shining on the cathode is increased. If you change the frequency of the light, what changes about the photons? Their energy. They have more energy. So each photon packs more punch. OK? One photon liberates 1 electron. And where the photons now have more energy, they pay a certain price to liberate the electrons. Where does that extra energy go? Kinetic energy of the electrons. So if I have zestier photons, higher energy photons, what's that tell me about the electrons? Moving faster. The electrons are moving faster. So A is certainly true. But let's think about B. How about B? The intensity stays the same. And the intensity is going to govern how many photons you have, right? And if the intensity stays the same, but the energy of each individual photon is increased, what's happened to the number of photons? It's decreased, actually. So there will actually be fewer electrons. But the fewer electrons, each one of them is going to have more energy. OK? So what's the correct answer here? A. They're moving at a higher speed. That was enough fun. I feel like doing another. Shall we? Yeah. OK. How about this? Same experiment, but the frequency stays the same, but the intensity is increased. What change does that make? Talk to your neighbors about this. I'll call for a vote in 30 seconds.
electrons per second or something like that. Density, like photons.
All right, let's take a vote on this one. What do we have? There'll be more electrons emitted. The frequency is the same. So each individual photon is going to eject an electron at the same speed, but I have more intensity, more photons, more electrons. So the answer is B. There are more electrons emitted.